and welcome to this session on the basics of SPD selection. So we're going to get into the nitty-gritty of the basics of surge and how to select your devices from that. Purely for the fact the regulations are great and we have our regulations there in BS 7671, but sometimes it's quite hard to apply them without knowing any background information on surge protection. So that's the aim today. We're going to build a basic little bit of knowledge on surge protection, and then we will go through the BS 7671 443 regulations to finish. I will be your presenter today, and I am Kirsty Johnson. I'm the Technical Sales Director for Surge Protection Devices Limited. So what are we protecting against with our surge protection? And I know this might sound like a bit of a silly question, especially with the name of my company. But for a lot of people, when they hear about surge protection, the first thing they think about is lightning. And lightning is a part of it, but it's a very, very small part of what we actually look at with surge protection. So an overvoltage is a short increase in voltage of the electrical system. So it's a very short, sharp spike, as shown here on this image. It's commonly referred to as a surge, and they've always been present in our electrical systems. And to be honest, we've been using them for decades within the electrical industry. It's been in very, very small little areas rather than the widespread use that we're seeing now. And our technology is getting very, very sensitive. Even the stuff we use day to day, like our mobile phones, extremely sensitive pieces of electronic equipment. So surge protection devices are there to protect that electrical equipment. So our surges can come from externally to the installation and internally. So if we start with our external, we have our direct lightning, which is what everyone thinks about, but I will be moving on to describing that a little bit more in a moment. We have nearby lightning strikes. We have switching surges caused by our distribution network, because as switching occurs in the network, we do automatically get surges appear. Everybody knows our standard voltage is 230 volt and it fluctuates from that, it's up and it's down, but we can get quite large spikes appear on that as well. And we can also get things like power cuts. So the power going off isn't so much of a problem, but when it comes back on, that high load can create quite a large surge in the system. And this is where, especially in the domestic market, we hear quite a lot of damage occurring. We also have surges that come from inside of our property, and this is something that most people aren't really aware of, but actually up to 80% of surges can occur inside the electrical installation. So we have things like switching surges, which literally are as simple as they sound. Every time you flip a switch and pull a load, you create a surge in the system in varying degrees. We can have inductive loads, generators, inverters, air conditioning units, lifts, all these sort of big pieces of machinery, as well as our tiny little pieces of machinery that we use in our homes, like the DC drivers in your washing machine, all create surges in the system. So surge protection devices are there to sort of bridge the gap between all these surges that are occurring every day and the sensitive technology that we're using. And that has led to some installations requiring surge protection in BS 7671. So we do have to consider direct lightning, but it's only in very specific circumstances. So when we have an external lightning protection system like this, so we have a spike on the roof and tape running down the outside, it's commonly seen on quite tall buildings, schools, churches, large city centre buildings, things like that. So they are designed to BSEN 62305, which is your lightning protection system. Now, for a complete lightning protection system, the external system must be cross-bonded to the incoming MET, and an SPD must be installed on the main incomer. So that SPD then sits there between the live electrical system and the MET to stop flashover from occurring. So stops the lightning from being able to get into that electrical system. This allows the lightning then to dissipate safely through the earthing system. Same sort of applies when we've got an overhead line. So an overhead supply cable is open to the elements, as we know, and therefore can easily be struck by lightning. So therefore we need a lightning protection device on the installation served by an overhead supply, not a surge protection device. They fall under the same category. They're all called surge protection devices, but we need a lightning protection device for that sort of circumstance. It's a little bit harder to think about when you've got a cable that goes underground from a pole mounted transformer. because people then think, oh, the cable's underground coming into the installation. But my advice would always be, if you can see the pole mounted transformer, the overhead come into the pole mounted transformer and then a short distance underground to the installation, my advice would be to treat it like an overhead supply, because the underground cable element of it in this diagram would not be long enough to dissipate the lightning effectively. We also have to consider indirect lightning effects. So lightning can also strike the ground, and when this occurs, we call it an indirect strike, and it can cause voltage disruption in the installations up to 2 miles away. Because it's not a direct strike, it doesn't need a lightning protection device, but we need a surge protection device, which can handle with that voltage disruption on the electrical installations. So I just want to run through in brief how a surge protection device works. So we know surge devices are there to send our surge to earth. So they essentially send our excess voltage to earth. Now it detects the overvoltages, dissipates it to earth and resets itself within 25 nanoseconds. They're installed in parallel with the board rather than in series. So in other words, they just tap off and monitor the voltage. It doesn't ever disconnect the supply and only removes the excess voltage. So it doesn't turn your power off like an MCB would. It just gets rid of that spike. And the indication that's on the surge protection device will only ever indicate when the device is at the end of its lifespan, not when it's taken a surge. So our devices, for example, come with a 10-year warranty. So they'll last for a minimum of 10 years before that indication will change. They'll have just been taking surges and resetting itself during that time. After that point, when it can't take any more surges, the indication will change over and it will need to be replaced. The handy thing with most of our devices are they are modular, meaning at the end of that lifespan, you just pull the module out and put a new one in. So we have 3 types of surge protection devices. We have our type 1s, which is our lightning protection devices, and they are there to protect against direct lightning strikes. We have our type 2s, which cover our indirect lightning strikes, so if it strikes the ground nearby, and our switching surges. And we have type 3, which protects local equipment against switching surges. So their devices are now usually sold as combined devices. So we have type 1s, type 2s and type 3s. But usually when you start looking at the data sheets, it'll be a 1, 2 and 3 combined unit or a type 2 and 3 combined unit. And all that does is provide protection for that board in the 3 phases. It doesn't negate the need for surge protection downstream. Surge protection devices are usually installed 1 per board. So say, for example, you install a type 1, 2 and 3 on the main panel, and then you have sub-panels. Your sub-panels would usually then have type 2s and 3s on. It just means for that panel, you have protection against direct lightning strikes and your switching surges. So to effectively protect the installation against all these voltage disturbances, we should use a cascade of SPDs. In other words, we use a type 1 on your main incomer if you need it, type 2s on your subs, and then if you have very sensitive electronic equipment like a fire alarm panel or a server rack that you want to protect, you'd usually use a type 3 there. So we do have a flow diagram to make this a little bit easier for you. So you can go through your important questions and it will give you a part number at the end. So working out, do we need a type 1 device by asking if we've got a lightning protection system or overhead lines. We then have to consider the earthing system at the installation because that's extremely important with device selection. And then we go, is it single phase or 3 phase? If you'd like a copy of this flowchart, you'd be able to get one from your local CEF branch. Most of them have got it on the trade counter, and I'm sure they'll be happy to send you a PDF copy if you need it. That's no problem. So we'll start having a look at the 18th edition regulations. So 443.4, protection against transient overvoltages shall be provided where the consequences caused by overvoltage could. Before we move on to the indents, there are a couple of things we need to look at. This is a shall regulation, meaning that if your installation falls into any of the categories, it must be installed. You can't say your client doesn't want it or decide it costs too much money. It needs to be done. The wiring regulations are not retrospectively applied. So these regulations only need to be applied when installing a new board or if you're making a significant amendment to an existing installation. So if you're installing one new subboard in a large installation, if the circuits on that board fall under the requirements in the indents I'm going to go on to in a moment, then you have to install the SPD on that board, but you don't have to install it on the rest of the installation. That is something you could recommend to your client, but it's not something you'd have to do. So the indents we have result in serious injury or loss to human life, result in the interruption of public services or damage to cultural heritage, result in interruption of commercial industrial activity, or affect a large number of co-located individuals. So result in serious injury or loss to human life is pretty straightforward. We've got to consider if any of them circuits on the board, if they were damaged, could result in serious injury or loss of human life. So if that board feeds something like a public fire alarm, emergency lighting, security systems, disabled pull cords, things like that, where anyone could get hurt if that went down, you would have to install surge protection. Result in the interruption of public services, it could be a public EV charge point fed from that board, you would put a surge protection device on it. Result in the interruption of commercial or industrial activity, could it lose your client money? That's what I always think about with that. So it could be a large piece of equipment that would cost your client a lot of money to repair, or it could be a piece of equipment within a factory that needs to be working all the time. So lost production could cost your client money. It could be direct, as in this board feeds the till system in the shop and they physically can't make any money if that goes down. That's when you'd install your surge protection under that indent. And the lastly is affect a large number of co-located individuals. So if you could affect a large group of people at the same time, then you would have to put surge protection in. The one I like to think about with this is like the lighting circuits in an exhibition hall. Whereas if it was at capacity and your lights went down, you would affect a large number of people. For all of the cases, a risk assessment shall be performed according to 443.5, which I'm going to go through in a moment. If the risk assessment is not performed, the installation shall be provided with protection against transient overvoltages, except for single dwelling units, so our domestic installations, where the total value of the installation equipment does not justify protection. So where the total value of the installation equipment. So that's what we've got to consider. As an electrician, it's very, very hard for you to make that decision that the total value of the installation equipment doesn't justify protection. So what's recommended here is you discuss it with the client. Recommend surge protection if you're putting in a new consumer unit. If your client doesn't want it, record it on your installation certificate that you recommended surge protection, the client declined. This will stop any issues further down the line if your client has any damage. It will just give you an added layer of protection for your personal indemnity insurance. So moving on to the risk assessment, I'm going to go through it in brief. It's not as complex as it looks, and there's very few installations where you actually would need to do it. We have our indents, which covers most installations, and we have our regulation for domestic. This is for all other cases. So our CRL is our calculated risk level. Our factor of the environment is given to us in table 442.1, which I've recreated here. So for a rural and suburban environment, we start with 85, and an urban environment, we start with 850. The LP we're going to calculate, which I'm going to move on to on the next slide. And the NG is the flash density of the area your installation is in, so the lightning flash density, and is given to us in figure 44.2. So it's page 102 in your regs where you've got that grayscale map. You pick where you are in the country, and that gives you a number to drop into the equation. Now, once the calculation is complete, if your CRL is above 1,000, protection against atmospheric transients is not required. If it's below 1,000, protection against atmospheric transients is required. Now, the wording is very exact there. What we've got to remember is this is calculating your risk of lightning damage. It's not calculating your risk of surge damage. And as we said right at the beginning, surges can occur inside the installation, and a lot of surges occur outside the installation. That's nothing to do with lightning. So it's really, really important, even if your risk assessment tells you don't require protection against atmospheric transients, it's not telling you don't need surge protection. So please be aware of that. And when you're looking at your installation, discuss it with your client if they don't fall under them indents, and work out how much their equipment is sensitive and how much it's worth to them, because you could have an installation that comes out and tells you don't need protection against atmospheric transients, but it could be filled with quite sensitive electronic equipment. So always discuss that with your client. The LP part we have to calculate. So our LP equals 2 LPAL plus LPCL plus 0.4 LPAH plus 0.2 LPCH. Now, if any of you are not mathematicians, like I'm not generally, that probably scares the life out of you anyway. But it's not that bad. If we break it down a little bit, LPs are just what we're trying to calculate. AL is above ground low voltage, so above is A, C is concealed low voltage. So we've got above ground low voltage, concealed low voltage, so underground, above ground high voltage, concealed high voltage. Now we only have to take into consideration the nearest kilometre to the installation, the nearest 1,000 metres. Now most installations you're going to work with won't have high voltage within 1,000 metres. There are some that are, but most of them won't. So for most installations, you've actually only got to consider half of that equation. Now, if you stand outside of the installation you're working at and you can't see any overheads, then it's 1 kilometre underground. So your LP then would actually equal 1. If you stand outside of your installation, you can see overheads and they're about 200 metres away from your installation. You'd put 0.2 in for underground to get you to that overhead, and then 0.8 in for your overhead to take you to that 1 kilometre. The difference is the overhead you've got to times by a factor of 2. So that is it running through it. That's running through your risk assessment. I know it was in brief. If you do require any more help with the risk assessment, please contact your local CEF branch and they'll be able to get in touch with me for any additional help. I have put the flowchart back up there if any of you want to screenshot it or anything like that to look at it. It is very helpful. But as I said, it will be available from your CEF branches. Thank you for watching. For more information, please contact your local CEF branch, or you can contact MCG Industrial or Surge Protection Devices Limited directly. I hope you've found it useful. Thank you very much.